Let's look at number 8. This one has a little bit more complexity to it just because there's a coefficient and a variable in the first term. And remember, we want to think of the second term right here as plus -1. So the first term is 3n, the second term is -1. We're taking the binomial to the 5th power. Remember, when you do that, every term has a coefficient from the triangle, the power of the first term in the binomial, and a power of the second term in the binomial. So if I call this A, and the -1 we call as B, there's a power of A, and there's a power of B, and then there's the coefficient on the term. And we're looking for the 4th term in the expansion. So we'll have to use Pascal's triangle to figure out what that bottom row is in the 6th row, because the top row is 1. We'll have to take the powers of A and wind them down, the powers of B and wind them up. So let's kind of lay out the powers of A on the downward trend. We're going to have 3n, and it's going to be raised to whatever the power of the binomial is. The binomial is being raised to the 5th power. That's going to have room for the coefficient from Pascal's triangle in front of it. We also want the power of B, and we know in the first term B is to the 0 power, and that B was -1, correct? So we're going to use -1, but we know anything to the 0 power is 1, so that whole idea is going to disappear, but I'll pencil it in for now. -1 to the 0 power. We know in the next term we're going to have a coefficient. We're going to have the first term of the binomial 3 times n, and it has to be 1 less power than the 5, which is 4. The B, on the other hand, the -1, it's increasing in its exponent. Next term is going to have a coefficient. It's going to have the A, 3n, raised to the 3rd term, 5, 4, 3, or the 3rd power. 3rd power. Meanwhile, the B term, -1, is increasing in its exponent. That's the first term, the second term, the 3rd term. We'll get to the 4th term and call it good, because that's all we're looking for. We could expand the entire binomial like this, but this is only asking us for the 4th term. That's going to be a 3n, and it's going to be raised to the 2nd power, and the B term is going to be raised to the 3rd power. I'm going to put dot, 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 because we don't need the rest of them at this moment. We simply need the 4th term of this expansion. So now that we know kind of how those terms are going, we're going to have anything to the 0 power makes 1. So this thing multiplies out and kind of removes itself. It reminds us that that second term, when you raise -1 to the 1st power, is going to be a negative in front of things. And we're going to have the 81, 3 to the 4th, n to the 4th. And our 1 to the power of 1 gives us a -1 that's implied here. We still have to have room for the coefficient from Pascal's triangle. That is going to still be multiplied by this in order to get the term. So we would do that on this next term. Squaring a -1 is going to give us a positive. That same idea, 3 to the 3rd, n to the 3rd, -1 times -1 is +1, so it doesn't really show up in the multiplication. In this 4th term, 1st term, 2nd term, 3rd term, 4th term, we have -3 to the 3rd power. It's going to be a negative term value. We're going to have 3 squared, which is going to be 9. We're going to have n squared. We've already taken care of the -1 to the third power, which gives us a negative value out front. It's just that remaining idea, the coefficient from Pascal's triangle, that's going to be multiplying as well. So let's take a moment and generate the triangle. Go down to the 6th row, because we know at the top of the triangle is a 1, and that's from anything to the 0 power, and then anything to the first power. Both have coefficients of 1 and 1 on whatever those two terms, the A and B, are in there. Next row, 1, 2, 1. That's for the second power. The third power, 1, 3, 3, 1. The fourth power goes 1, 4, 6, 4, 1. And the fifth power, that's exactly what we're trying to generate for this question. The fifth power goes 1, 5, 10, 10, 5, 1. Moving terms out of the triangle, this is the coefficient on the first term, the coefficient on the second term, third term. We are going to use the coefficient of 10 on this term in our binomial expansion. So when we do the multiplication, we have 10 times the 3 squared times the n squared times -1 to the third power. We end up with a term value of -90 n squared. And that is how we go through the entire process of generating and predicting what a specific term in the expansion of any binomial, how it's located, using the terms. Remember, we always have to use a sum, 3n plus -1, the A, the B. Again, powers on the A wind down as you move across your term values. Powers on the B wind up as you move across with the term values. If your B was a negative idea, you're going to have to pay attention to those odd powers on the exponents. They're going to generate the negative term separating signs between the terms of the polynomial expansion. Hopefully that makes good sense to you. I know it's kind of weird and abstract. I told you it's one of those stair-step building ideas, but I'd like you to try to do some of the rest of those. You've got several other ones here. I would try another -1 right now, maybe number 7. A equals y and B equals -3. You already have the 5th row of the triangle from that last problem, so you can focus on generating those powers of A and B and getting to the 4th term of the expansion. We already know the 4th term's coefficient, so that's nice. The 4th term's coefficient is going to be exactly the way it was on the last one. It'll be the 10. Good luck. I'll be in tomorrow. I'll even be here, tomorrow, and we'll go over some more of this then.